That was nice. Can you hear me? Yes, I can hear myself. Sorry. Hello, everyone. Welcome to my TED Talk. No, just kidding. I hope you're having fun. You're enjoying the event. Clearly today, I'm going to be talking a lot about security and AI, of course, because that's what we're here for. But I wanted to do like a strong start, and I'm going to go ahead and say it. You cannot trust AI. You simply can't. You can't trust it. If you think about it, you're feeding a lot of information and context into somewhere that can potentially expose this data. Because, you're just feeding it there, right? But I mean this also in the best possible way. Like, you wouldn't trust AI the same way you wouldn't trust a random human out there. So today, I'm here to talk about how can we secure our AI applications, but also to talk about authorization and how, along this journey of different access control systems, we can go ahead and solve this problem. Now, before we jump into everything, allow me to introduce myself again, because I had a very nice introduction just now. 1 second. That's better. OK. My name is Carla, and I'm a software engineer. I've been working as a as a developer advocate for about 3 years already with Auth0. And I love specialty coffee. I've recently embraced that as my thing. I love coffee. I'm a coffee person. Is there like any other coffee people here? My people, thank you. So if you want to talk about coffee later on, find me at the Auth0 booth. If you also want to connect to talk about coffee or tech or anything, you can find me as Carla Stabile, pretty much anywhere in the internet, except on LinkedIn, where you have to use my full name because we're more formal there. And yeah, let's get started. Let's see. So AI is evolving at an incredible rate. The things we could do 2 years ago have nothing to do with the things we could do 1 year ago or even last month. I don't know if you remember, I don't know, maybe a couple months ago, I don't even know how long ago, you would generate AI images, and they would get the hands and the fingers very wrong, and all the images were like very strange. Right now, that's not necessarily happening anymore, so it's evolving super, super fast. And the thing about security is that security doesn't evolve as fast. It really needs to catch up with AI. So that's why we are here to talk and discuss all that information. So if you know, clicker work. Hello? Oh, wait. Nice. So OWASP defined the top 10 LLM risks. They started doing this back in 2023, I believe. And it started as a community-driven effort to, let's figure out what are the risks and how, most importantly, how can we mitigate these risks. So I'm going to show you the list for 2025. And I want you kind of reflect on the applications that you're building if you think any of this can happen to you. Spoiler alert, yes. But they're in order, OK? So we're going from the top 1 onto the 10. The first one is prompt injection. So that means when your user uses a prompt that can potentially damage your system or, make weird stuff happen. The second one is called sensitive information disclosure. And that basically means exposing, for example, personal identifiable data, information that is just simply private for a company that shouldn't be out there, that kind of stuff. Number 3 is supply chain attacks. So often when we're developing this apps application, we could use a third model system, and then we don't know exactly what vulnerabilities that can have, and so we might be introducing those into our application. Number 4, data and model poisoning. So whenever you're training or embedding your data, it could happen that you might be introducing as well some vulnerabilities. Number 5, improper output handling. This is basically when you don't do the right sanitation and verification on your outputs, and it can also can generate vulnerabilities. I'm going to say that word a lot. Bear with me, because it's a hard English word for me. Number 6, excessive agency. So for those of you building AI agents out there, as you know, they're autonomous and they can do things for you and whatnot. But it could happen that they might get like too much, how do I say, English word, come to me. You might give them too much liberty or like freedom to do things. And that's what I call excessive agency, and that could potentially lead to security issues. Number 7, system prompt leakage. This is about when the instructions that you have for your system or your applications could be exposed. You need to make sure that those are secure. Number 8 is vector and embedding weaknesses. Also, again, the way you store your vector and your embeddings, that also has to be secured. Number 9, misinformation. So whenever you get any false information or information that can be misleading, this often happens with hallucinations and that kind of stuff. And finally, number 10 is unbounded consumption. Nice, yes, Kane, that's what I brought it for. Unbounded consumption could happen, for example, when someone tries to overload your system, putting a lot of different prompts of different lengths, and just overloading it, basically. So these are the top 10. Do you see that maybe one of your systems could be affected by any of this? Like, if you can raise your hand. I'm going to ask you to raise your hands a lot, because it just makes me feel less alone here. So please do it, please. Cool. So yeah, this is the top 10. Some of them we can control, some of them we cannot control as AI developers. So I wanna focus this talk on one of them, and it's gonna be number 2, which is sensitive information disclosure. So as I said, sensitive information disclosure can happen whenever your AI agent, for example, exposes private information that wasn't supposed to be shared. And for example, think of it this way. You're a developer and you work at a hospital. And let's say at the hospital you have this AI companion where you could ask questions about, I don't know, let's say a disease rate. Like, how many people have had this in the last 3 months? So as a developer, you shouldn't get information of, for example, who had this disease and when, right? This is super illegal and against data protection laws. So how can you make sure that the right information brought by this AI companion gets to the right people? And the answer is with authorization. So if you remember, authorization basically means who can do what, who has access to this resource. And I'm going to spend some time talking about authorization. That's why we're having this journey, right, through access control. Because I think it's very important for us to understand that if we understand authorization on a non-AI context, we can extrapolate that information into the AI context. There is a few things that might change, of course, because they're different use cases. But the whole idea about it is the same. So whenever you start thinking of authorization, often the first step is actually authentication. So you're thinking only authenticated users can access this page or this website or whatever. Obviously, if you think about it, authentication might not be enough for what you want to control and access, right? So then you decide to take it a step further. You're like, okay, I need to maybe introduce something new. And then you start thinking about roles. In any organization, we have the concept of roles. For example, if we have IT admins, they have access to the server racks, for example. If we have an HR person, they have access to employee data, and they don't necessarily have access to the same stuff, right? So role-based access control means assigning permissions to users based on their role within an organization. But if you think about it, we're thinking about roles, so roles usually involve a group of people, right, or a group of users, so to say. So we have this group of people that have access to do this one thing. So if I'm thinking on the context of AI, unless you have a very simple use case where you're saying, maybe a data reader role would be enough for me, this could work for you. I want to see, does having a role like that would work for any of you? For those of you who are developing AI applications? Nice. I see one hand, that's nice. Okay, awesome. So it seems that it might work, but it really depends on your use case. So we're going to take it one step further, and we're going to say, how about we can only control, not only with roles, but also with attributes, right? Let's say I want to say, I only want these users to access this website from a certain IP address or from a certain time of the day. That would be attribute-based access control, also known as ABAC. And it consists of assigning permissions to users based on assigned attributes of an entity in your system. So for example, let's say your user entity has an IP address field, then you can filter using that, something like that, right? Again, we're kind of limiting more the access. We have a little bit more granular control over who can access what. But do you think using an attribute could suffice your use case of whatever you're building? Maybe you're already using ABAC. No? Cool. There's no wrong or right answer, by the way. It's just, as usual, as software developers, it depends. So we can take it one step further and say, you know what? How about I grant access based on the relationship between the entities of my system? And this is known as a relationship-based access control. This is normally used like in social media applications, for example. Like if we are connected, then I have access to see more or less information about yourself, something like that. And because we're defining relations, the way you define those relations allows you to also maybe define roles and define attributes. And so when you use RBAC, you could also use ABAC or RBAC. So this kind of like encapsulates all of them if you want to, or if you needed to. Now, I've asked this like a couple times, but now this is the last time I ask you this. Which authorization system do you think work best for AI applications? Is it RBAC that uses roles, is familiar and straightforward because we're kind of translating our organization rules into a system? It offers you a more coarse access control. Is it ABAC, which is based on the attributes of the entities of your system and gives you a little bit more granularity than RBAC? Or is it RBAC, which is based on relationships and gives you finer access control? Any ideas? Just shout at me. It depends. Someone said, honestly, great. I love that answer. It's RBAC, actually, but it's RBAC with a little bit of a twist. So the twist is called Fine-Grained Authorization. And Fine-Grained Authorization uses RBAC, for example. There are different implementations out there that you can use and allow you to grant access to users, AI agents, whatever you want, to entities. Let's call it like that, entities, based on the relationship those entities have with these other entities. And it allows you to go very specific into, okay, I'm going to grant access to this specific resource at this specific time because it is Sunday. I don't know, I'm just making that up. But it allows you to be very, 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 very specific, and fine. That's why it's called fine-grained authorization. Like I said, there are a few implementations of it. One of this is called OpenFGA. Okay. One of them is called OpenFGA. So this is an open source authorization system that allows you to make checks and verify that a user has a certain relationship with an object. It's actually inspired by Google's authorization system, Zanzibar. And it's open source, so you can go and take a look if you want. Now, there are three main things you need to know about OpenFGA, which is stores, authorization models, and relationship tuples. So the store would be where you define and put your authorization model, your relationship tuples, and all your information. So it's literally where you store your data. The authorization model is where you define who can do what and under which conditions. So this is kind of like where you define the rules of your system, right? The relationship tuples refer to those, it's actually like tuples or triples consisting of a user, an object, and a relation, sometimes a condition as well. And you can consider them like the facts of your authorization system. So the authorization model says, these are the rules. And then with your tuples, you can say, actually, Carla has access to this through this relation. And then you can also use the API endpoint. So the way you communicate with OpenFGA is through a REST API. And you can use the check endpoint, which is, in my opinion, one of the most important endpoints, because it's actually the one that says allowed true or allowed false to whomever is requesting access. And then you can also list the objects that are related to a user and list the users that are related to an object and all sorts of things. It's a very powerful API. Now, this is how it looks like. If you were to play around, if you look OpenFGA Playground, this is what you would see. On the top left, you will see that I have a store. This store is called test. And on the left side, I have an authorization model, which has some things, has a couple types, has some relations. I'm going to talk a little bit more in depth about this authorization model in a bit, so I just want you to get the overview first. And then on the left side, but at the bottom, we see the tuples. So in this case, we're saying user Carla is an owner of doc roadmap, and user Anne is a viewer of doc roadmap. And then on the right side, you get like a graph view of how your authorization model looks like. So yeah, this is how OpenFGA looks like. Now, back to AI, right? Because obviously I'm talking about authorization and users, but we really want to know how to make our application secure. That's the whole point. Let's think of an example. Let's assume we are building a RAG-based AI assistant, and this assistant can, for example, retrieve the forecast for a given company, a company that I'm going to call Zico, because why not? And obviously, the information that I would get as a developer, for example, shouldn't be the same. This is my assumption from my system, OK? So it's not going to be the same that someone from the financial team is going to get. If I ask for the forecast, I might use some information, but if someone from the like the CFO is going to get probably a lot more information than what I should see, right? So how would this look like? Hopefully you can read it. Yes, hopefully. This is kind of like the workflow of the application we want to be looking at. So we have the user John Doe that is going to ask a question, and the question is, show me forecast for Zico. That is not a question, but OK, it's an order. And what's going to happen is, in this application, we're going to do a semantic search, and we're going to query a vector store and get the relevant documents. We're also going to assume that we have private and public documents. And so the CFO can see the private ones. The rest of us can't, right? That's what we're going to assume. So once we ask the question, we do the semantic search. And for this, in this application, we're going to be using the OpenAI SDK to make the query and the search and whatnot. But once we have that information, once we have the documents that are related to this search, we're going to filter the documents based on the user permissions that we're going to define using the OpenFGA SDK. So if you see in the image, there's 2 documents that are green and 1 that is red. That means I'm not going to provide you with that information because you're not allowed. And so the question is going to be answered using only the relevant documentation, right? So remember we were talking earlier about the authorization model, which is where you define who can do what. How would that look like for this particular example? It would look like this. So we're going to have a model, schema 1.1. That's just the version that we're using right now, standard. And then we have 2 types. We have the type user, which at this point has no relations or anything. Just we're saying there is a type. It's called user. Great. And then we have another type called doc. And type doc has 2 relations. We have the relation owner, which can only be assigned to a user. That's what that syntax means. And we have the relation viewer, which also can only be assigned to a user, but it could also be assigned to anyone, meaning that user : asterisk syntax means it can be kind of like a public document. Everyone can be a viewer of a document if I decide they can be a viewer. So once we have this authorization model, we can put that into OpenFGA, and it would look like this, which if you notice is the same example I showed you earlier, but now you have more context. And I have a couple tuples there. I said user Carla in the left bottom side. I said user Carla is an owner of doc private, and user Jess is a viewer of doc private. So at this point, we have set OpenFGA with the information that it needs to know about our application. Like that, like magic, because we already did it. So how would the workflow of this application look like? And I want to show you the workflow, like overall look of it. Because if we look deeply into the code, we're going to be here for a while. So this is built in Python. And we're gonna talk a little bit about what's going on here. This is basically the main.py file, so this is where everything is happening. This is our algorithm. So we're gonna go step by step. Well, we're gonna be asking, show me the forecast for SICO, right? And what's gonna happen first is we have a helper class called local vector store, where we're gonna create an index and use OpenAI to interact with our application. So we're kind of like encapsulating our interaction with OpenAI, with the OpenAI SDK in this class. And so we're saying, give me the documents. In this case, we already loaded documents, private and public, into these variable documents. And then we're going to perform the query. So what we're doing is, based on those documents, I want you to tell me the ones that actually make sense for this question with that distance, right? So again, this is all happening on that local vector store that we have there. Then we're going to convert that search result into a document with scores. Also, a helper class where we're going to say this document has this score, and then based on a threshold that I want to define, I'm going to say if this is relevant for me or this is not relevant for me. So that's basically what that's doing. And then we go to my favorite part. That's when we are actually interacting with the OpenFGA SDK. So what's happening here is we have an FGA retriever class. This class, again, is encapsulating all the API requests that we're doing to OpenFGA. I know, I should have done it earlier, but it is what it is. Okay. So we're encapsulating all there, and what we're doing is we're creating a new client, creating that connection, and we're saying we have these documents, and I want you to build this query. The query is, given this user and these documents, are they a viewer? Basically, are they allowed to see this document? That's how we're defining it in this application. And then we're going to call the retrieve method and actually make that request, right? Cool. And we're going to filter them out, of course. That's what the retriever method is to it. Lastly, we're going to generate a response based on that context. This generate function, again, is also a helper function where we're using OpenAI. This is where we're defining all the instructions for our prompt and stuff. So that's our helper there. And then we're going to print the answer. And this is basically how you would kind of integrate OpenFGA with a RAG application, a simple RAG application. Now, if you want to learn more, you can take a look at the blog post from my colleague, who basically did a very extensive guide on this particular example. You can also get the sample code as well. And of course, you can check openfga.dev, because that's what that is there for. I thought I was going to have time to demo it quickly, but I might not have time. So the other thing I wanted to say is we're doing a giveaway. So we're giving that Keychron K10 keyboard away. All you have to do is tell me what you're doing with Gen AI nowadays and your name, and come by the booth, the Auth0 booth at 4 p.m. for the giveaway. I see some people scanning, so I'm going to leave that there for a moment while I do a little dance. It will be at the TB booth as well, so you can scan it there. And I mean, if you follow all of this and understand about authorization, now you can trust AI. So thank you very much, and enjoy the rest of the event.